Welcome to Prince Maths Clinic, the e-learning solution at your pace and time.
Good day, viewers, and compliments of the season to you wherever you find yourself in the world. Here we have a very interesting question to show that 2 to the power of n minus 2 to the power of n minus 1 equal to 2 to the power of n minus 1. But before we continue, kindly click on the share button on the Facebook page, and if you are on the YouTube channel, kindly subscribe to the channel and share this video so that it can go viral. All right, looking at this question, we have 2 to the power of n minus 2 to the power of n minus 1. We want to show that it is equal to 2 to the power of n minus the left hand side is equal to what you have at the right hand side. So I'm going to use this as my first method, so method 1. Now I want to use the factoring method. I want to factor out, there's a common factor here and here, and I want to use that. Now, and what do I want to use? I want to factor out 2 to the power of n minus 1. This is n, right? N is actually greater than n minus 1. So I can factor n minus 1 out. So I can say 2 to the power of n minus 1, open bracket. Now based on the laws of indices, I can say this is 2 to the power of 1, 2 to the power of 1. Now remember, I factored out 2 to the power of n minus 1. So this leaves me with just 1 left, right? Now, I'll put equal to 2 to the power of n minus 1. Now, 2 to the power of n minus 1, in bracket now, 2 to the power of 1 means 2. Then minus 1 equal to 2 to the power of n minus 1. Now, 2 minus 1 is simply 1. So therefore, 2 to the power of n minus 1 times 1 equals to 2 to the power of n minus 1. So this implies that my 2 to the power of n minus 1 equal to 2 to the power of n minus 1. That is the method 1 to solve what? This question. So you can show that the left hand side is equal to the right hand side. Good. Now let's look at the second method. Let's look at the second method. Method 2. Now, in the second method, you have 2 to the power of n minus 2 to the power of n minus 1, right? Equal to 2 to the power of n minus 1. Now, based on the laws of indices, we know that this part, this portion here, which is 2 to the power of n minus 1, can be written as 2 to the power of n divided by 2 to the power of 1. So instead of writing 2 to the power of n minus 1, now this is what I'm going to replace it with what is going to be 2 to the power of n minus 2 to the power of n here divided by 2 to the power of 1, which is equal to 2 to the power of n minus 1. Now, watch what I'm going to do. I want to use the LCM method. Now, in the previous videos, I've showed you how to use the butterfly method to solve fraction. I'm going to apply that in this particular video. So you can check the description of this particular video to see that solution on how to use the butterfly method to solve fraction. So now I'm going to do 2 times 2 to the power of 1 times n, 2 to the power of n, 2 to the power of 1 times 2 to the power of n. So I'm going to n plus times 2 to the power of 1 minus, then 1 times 2 to the power of n gives me what? 2 to the power of n. Everything over 1 times 2 to the power of 1 gives us what? 2 to the power of 1. Now everything is equal to 2 to the power of n minus 1. Now, since I have 2 to the power of n in common, I'm going to bring 2 to the power of n out, open bracket, then I'm left with 2 to the power of 1 here, minus, so this is out, so this is 1, over 2 to the power of 1. Now, and 2 to the power of 1 means 2, so equal to 2 to the power of n minus 1. Good. 2 to the power of 1 is still 2, so 2 minus 1 is 1. So here we have 2 to the power of n times 2 minus 1 is 1. Then remember, you have an over 2 here, right? Don't forget, you have an over 2 there, equal to 2 to the power of n minus 1. Is that clear? Good. So what does this mean? Half is the same thing as 2 to the power of minus 1. So therefore 2 to the power of n times 2 to the power of minus 1 equals to 2 to the power of n minus 1. So the base are the same, so you can add the power. So therefore 2 to the power of n minus 1 equals to 2 to the power of n minus 1. So QED. That is the solution to this question.